Hello, good morning everyone. I am Dr. G. Seshadri, working as a Associate Professor in Electrical and Electronics Engineering Department, Institute of Aeronautical Engineering. Today I want to discuss about AC machines. So today our title is AC machines are classified as generators and motors. AC generators are also called as alternators and synchronous generators also, and motors. So we know the basic principle for generator and motor. So motor actually takes electrical energy and supplies mechanical energy. Similarly, we give input mechanical energy to the generator and it will convert the mechanical energy into electrical energy. So here, depending upon supply, machines are works on AC supply and DC supply. So DC supply, the machines are generators and motors. So DC generator and DC motor. So DC generators, and also depending upon the magnetic field, there are three types of fields are there. First one, constant or steady magnetic field, and pulsating magnetic field, and rotating magnetic field. So this magnetic field is required to generate an EMF, to produce an EMF. So generating EMF, the required mainly flux and conductor. So flux means magnetic field and a conductor is required. So what is meant by constant magnetic field or steady magnetic field? A magnetic field that is same in time, it is constant with respect to time, constant with respect to time, that is same strength, magnitude and same direction at any instant of time. At any instant of time, it is constant. At any instant of time, it is constant. And same direction. And what is meant by pulsating magnetic field? So, pulsating magnetic field, it is produced by an electromagnet where a brief current is applied instead of a constant current. So, instead of applying a constant current, a brief current is applied here and a pulsating magnetic field is produced. This creates a magnetic field that pulses in time with the frequency of a current. So pulsating magnetic field is generated by two-phase AC supply only. So depending upon supply, the induction machines are classified as single phase and polyphase. And the word rotating magnetic field. So it is a resultant magnetic field produced by a system of coils symmetrically placed and supplied with polyphase currents. So depending upon the supply, the single phase AC supply, the motor works called single phase induction motors, and three phase supply, by using three phase supply, these are called polyphase induction motors. Okay, so 85% of the motors are induction motors now widely using industrial. For three phase motors are widely used for industries, and these are called polyphase motors, widely used in industries, and remaining single phase induction motors are used for domestic purposes, domestic applications. So here, depending upon the supply, single phase and polyphase. Also two or more phase also there. It is called polyphase motors. So a rotating magnetic field can be produced by a polyphase current or by single phase current. So two field windings are supplied and are so designed that the two resulting magnetic fields generated thereby thereof out of phase. That is nothing but whenever a three phase supply, it is singly fed machine. Uh, Here we are giving a three phase AC supply to the stator, and it is nothing but a rotating magnetic field is produced in the stator windings. So it is the resultant of magnetic field produced by a system of coils symmetrically placed and supplied with polyphase currents. So whenever a three phase supply is given to the stator winding, a rotating magnetic field is produced, or by a single phase current provided that in latter case two field windings are supplied and are so designed that the two resulting magnetic fields generated thereby out of phase. So rotating magnetic fields generated by three phase AC supply, and according to the Faraday's laws of electromagnetic induction, Faraday's law, whenever a conductor cuts the magnetic field, an EMF is induced in that conductor. EMF is induced in that conductor. Here, the main advantage of a rotating magnetic field is a comparatively less power required. Less power means less sparking or losses across the slip rings are less. So because of rotating magnetic field, it requires less power. It is possible to make alternator completely brushless. So here brushes are used and alternator completely to make alternator completely brushless. So rotating magnetic fields are often utilized for electromechanical applications such as induction motors, electric generators, and induction regulators. So here the three-phase induction motors are mainly used in industrial purpose, and there are two types of according to the rotor construction, there are two types of induction motors. They are nothing but squirrel cage induction motor and wound motor or slip ring induction motor. Slip ring and squirrel cage induction motors. SQIM are also called as squirrel cage induction motors. So here the basic working principle is Faraday's laws of electromagnetic induction, and here rotating magnetic field produced. So to produce the rotating magnetic field, there are two conditions to be satisfied. So one is three phase windings are displaced by 120 degrees electrical with respect to space, and currents allowed in the winding should be time displaced by 120 degrees. 120 degrees. And the types of rotors are the induction motor has two types of rotors. That is one is a squirrel cage induction motor, squirrel cage rotor, and another one is slip ring or wound rotor. So what is the advantage of squirrel cage rotor and what is meant by squirrel cage? So it is a cage type. The rotor core is cylindrical and slotted on its periphery made up of silicon steels. So slots are made up of silicon steel, and the rotor consists of uninsulated copper or aluminum bars called rotor conductors. Rotor conductors. So conductor is required to cut the magnetic flux. So here the uh, copper or aluminum bars are used for this purpose, for cutting the uh, magnetic flux. And the rotor slots are semi-closed type. There are three types of slots are there: open type, closed type, and semi-closed type. Open type, closed type, and semi-closed type. Here semi-closed types are used. Slots are used. The rotor conductors are placed in these slots. Now the rotor frequency range is 2 to 3 Hz. Rotor frequency is 2 to 3 Hz. It is less than the supply frequency. So if the supply frequency is 50 Hz, the slip will be in the range of 4 to 5%. So 4% means 2 Hz, and like this it varies from rotor frequency varies from 2 to 3 Hz. Therefore, eddy current losses, because the frequency, that means the iron losses depends upon the frequency. Iron losses depends upon frequency. Hysteresis loss also depends upon frequency, and eddy current loss also depends upon frequency. Iron losses or constant loss is also called as constant losses. So mainly constant loss are depends upon frequency. So the rotor frequency range is up to only 2 to 3%, 2 to 3 Hz. So since the frequency is low, rotor frequency is low, therefore eddy current loss are also very low. So eddy current loss are also very low. And these copper bars are permanently short circuited at both sides with the help of conducting copper rings called end rings. So with the help of end rings, the rotor bars are short circuited at each side. And these end rings gives good mechanical balance to the rotor bars. And production of rotating magnetic field. How the rotating magnetic field is produced means whenever a three-phase AC supply, balanced AC supply is given to the stator winding, it produces three-phase voltage EMF, the rotating magnetic field in each phase. So let us say this is radical wave represents the sine wave represents the phase one, the flux produced by phase one, and the flux produced by phase two, the dotted line showing dotted line. This is flux produced by phase two, and blue line, blue waveform, it is nothing but the flux produced in phase three. With respect to theta or omega t, or with respect to time, we will take the amount of flux produced. So here it is the pure sine wave, and it is starting with 0 and reaches maximum at 90 degrees and reaches to 0 at 180 degrees, and in opposite direction it will produce maximum EMF at 270 degrees, and it reaches to the 0, it is nothing but 360 degrees or pi. So it means that the waveform, one cycle is completed, one positive half cycle and one negative half cycle is completed with theta equal to 360 degrees or time 2 pi radians, or velocity, angular velocity 2 pi radians. So one cycle is completed, one positive half cycle and negative half cycle is completed within 2 pi radians, and after that it repeats second cycle like that. If after some angle, phase 2 starts producing a flux, and similarly after 120 degrees electrical, phase 3 starts producing flux. So here we can observe that at phase 1 it starts at 0, and after 120 degrees phase 2 starts producing flux, and after 120 degrees it starts producing flux in phase 3. So from this we can observe that these three are three phases. Here it is phase 1, and after 120 degrees, so if we assume that it is rotating in anti-clockwise direction, and anti-clockwise direction, after 100 degrees it starts, after electrically displaced between phase 1 and phase 2 are 120 electrical degrees, and again spaced phase 3 120 degrees from phase 2. So electrically, so these are electrical degrees separated by 120 degrees, 120 degrees, 120 degrees. and advantages of three-phase induction motors. Okay, we'll see advantages. Before that, we need to write the flux produced in. So here EMF E1 phi equal to the generalized equation for sinusoidal waveform is equal to phi equal to phi m sin omega t or phi m sin theta. Phi m sin omega t. Similarly, the voltage expression for the pure sine wave is nothing but V of t equal to Vm sin theta or omega t. Similarly, the current waveform I of t equal to Im sin omega t. The voltage produced in or flux or current, whatever it may be, the voltage produced in R phase equal to Vm sin theta or Vm sin omega t, and the voltage produced in phase B is nothing but it is displaced 120 degrees electrical to the phase Y, phase R, and phase B the voltage produced in phase B is Vm sin omega t minus 240. It means with respect to R phase, the Y phase lags 120 degrees and B phase lags 240 degrees. Phase 2 or phase 1. So from this, it is from R phase to Y phase or phase 1 to phase 2, it is 120 degrees. Similarly, from phase 1 to phase 3, it is 120 plus 120, 240. So total, these are the expressions for generated EMF and voltage produced in a three-phase machine. Now, advantages of three-phase induction motors. So these three-phase induction motors, there are huge applications, wide applications in industry. So three-phase motors are used in industrial purpose, and single-phase motors are used for domestic purpose. So the most common type of motor, AC motor, is being used throughout the world today is induction motor only. So applications of three-phase induction motors are size varying from half kilowatt to thousands of kilowatts. Half HP are also called rated in HP also. So from half HP, 1 HP, 1.5 HP, like that, different ratings are there for single phase motors also. Two thousands of kilowatts ratings are also there, called megawatts. The advantages of three-phase induction motors are very simple in design. So design is very simple since it is having only a stator and rotor, and rugged in construction. So the operation also very reliable. Operation also very reliable operation, and cost also very low, and easy operation, and also simple maintenance. Simple control gear for starting and speed control. So various speed control methods are there. So we can control the speed, and it has high efficiency. So it has like DC generator, it has a constant speed uh, characteristics, and also it runs somewhat less than the synchronous speed only, somewhat less than synchronous speed only. So these are runs nearly nearly to the synchronous speed. So these are called asynchronous motors. Asynchronous motors. The relative speed between rotating magnetic field and actual rotor speed is called relative speed. So in this, the it has uh, the rotating magnetic field produces a rotating magnetic field at synchronous speed, at synchronous speed. So what is meant by synchronous speed? Synchronous speed is equal to 120 into supply frequency upon number of poles. Where F is the frequency and P is the number of poles. Suppose a two-pole machine, 50 Hz, the supply frequency runs with the synchronous speed 120 into 50 divided by 2. It runs with 3000 RPM, revolutions per minute, or rotations per minute. Revolutions, 3000 revolutions per minute. It runs with 3000 revolutions per minute. And construction similar to the DC machine, it has a magnetic frame called stator. So it is also called stator frame and stator core and distributed windings, two end covers, bearings, etc. Some parts in the stator. So it is nothing but a hollow cylindrical in shape, and it is made with cast iron. It is nothing but a stack of cylindrical laminations which are slotted along their inner periphery for housing a three-phase winding. So thin laminations are staggered and riveted, bolted in the stator core. And the stator core is made up of laminated silicon steel in order to reduce the hysteresis and eddy current losses. So hysteresis loss and eddy current losses can be reduced by taking good material, and also eddy current losses can be reduced by laminating the core. So induction machine, the poles are distributed over the entire surface of the stator. Poles are distributed over the entire surface of the stator. And are not visible. Here, physical poles are not there. The stator winding is constituted for required number of poles, depends upon the speed. Since speed is depends upon number of poles, so if the number of poles are more, the speed will be less. If the number of poles are less, the speed will be more. So depends upon the required speed, the stator winding is constituted for the required number of poles. So here the poles are not visible, so it is constructed. And then the rotor is short circuited in the squirrel cage induction motor, so no external resistance can be introduced for the purpose of any speed control or something. So Here, the rotor bars are placed instead of parallel. Here, squeed with some angle. It is called skewing. So it reduces the magnetic locking. So for the purpose of magnetic locking, so because of magnetic locking, at start it refuses to start. So to reduce that one, we have given some angle to the rotor bars. So this is called skewing. So advantage of skewing is nothing but the flux distribution is uniform and the operation of machine is silent. So no sound will be there when it is running, and magnetic locking also or tagging can be reduced. It is nothing but rotor bars are slightly skewing. These are the end bars. They are short circuit bar. The bars are short circuited at the ends. The short circuited. These copper bars or aluminum bars are short circuited. So it is called skewing. And general features of squirrel cage induction motor. So general features of these are there are no definite number of poles on rotor, but same number of stator poles will be induced in the rotor automatically. So means induction due to which this type of rotor can respond automatically to changes in stator number of poles. And the air gap between stator and rotor. So the air gap between stator and rotor has low leakage flux and low leakage reactance. The amount of power transfer from stator to rotor is high. So whenever a RMF is induced in the stator, it links the rotor conductors through air gap. So therefore, its torque production is capability under running conditions is good. Slip ring or wound rotor. So in this type of construction, rotor winding is similar to that of stator, and the rotor construction is laminated and sorted as in the squirrel cage induction motor. And the slots, the rotor slots containing rotor winding. The rotor winding must be provided with some same number of poles as that of stator. They are the same number of poles as that of stator. This type of rotor cannot be responded to the changes automatically to the changes in stator. That is why rotor poles must be changed physically along with the stator poles. So the three-phase rotor windings are always connected in star. Three-phase stator windings are always connected in star instead of delta. Whether rotor winding always connected in star instead of delta, and coming to the stator windings, they are connected in star or delta. Here, the three ends of three-phase windings are permanently connected to the slip rings. So here we use slip rings to add external resistance. We can add there. So these slip rings are mounted on the same shaft. Same shaft. So slip rings are made up of phosphorus branch, and the insulation between slip rings and shaft is mica. The external resistance can be added with the help of brushes here. We use carbon or graphite brushes to, and the slip rings arrangement in series which is each phase of rotor winding. So these are the here the slip rings are shown, and these are mounted on the same shaft here. So here slip rings are used, brushes are also. So the external resistance is connected here. external resistance. So we can vary the resistance of each phase. Stator and rotor, where the stator and rotor, it has a rotor winding, stator connected star connected winding. On rotor we can connect this in star. In stator we can connect star or delta, the stator windings. The functions of external resistance, by the advantages of adding external resistance through slip rings means in the slip ring induction motor. So because of that, it increases the starting torque produced by induction motor. It increases the starting torque, also increasing the rotor power factor at the time of starting. Rotor power factor also can be improved. It limits the starting current drawn by the induction motor. Therefore, no external starting methods are required to start this induction motor. So at the time of starting, the starting currents are very high. So because of high starting currents, the stator windings may get heated and may get burnt. So we need to reduce the high starting torque, high starting current. For this purpose, at starting we use external resistance, and after getting some acceleration, we will gradually cut out these resistances, and after getting normal speed, completely we will remove these resistances. So by adding these resistances, we can reduce the starting current. We can limit the starting current. So the purpose of adding external resistance is we can limit the high starting currents. So if external resistance is varied, running condition, then the speed of induction motor will be controlled. So this method of speed controlling is called resistance speed controlling method. So in running condition, a leakage flux is high, and hence leakage inductance of rotor is high, and hence leakage reactance of rotor is also high. Therefore, power transfer from stator to rotor is less, and the machine has less running torque. A slip ring induction motor has good starting performance but inferior running performance. So here it is good starting performance. It is having high starting torque. And coming to the comparison, so slip ring induction motors and squirrel cage induction motors both are used for industrial purpose, but depending upon the construction design, it has some features. So in squirrel cage induction motor, rotor type we use squirrel cage type rotor. In this squirrel cage type rotor, the ends, the rotor permanently short circuited rotor bars. It is having rotor bars with permanently short circuited. And coming to the slip ring induction motor, point type rotor or slip ring rotor with a three-phase winding similar to stator winding. Construction is simple for squirrel cage, somewhat complicated because of slip rings and brushes in slip ring. So external resistance we cannot add. It is very impossible to add this any external resistance because rotor bars are permanently short circuited. So we can't add any external resistance for squirrel cage induction motor. But it is possible to add external resistance for slip ring induction motors by using slip rings and brushes. So starting torque is somewhat low in case of squirrel cage induction motors, and starting torque is high in slip ring induction motors. So brushes, no need of brushes in squirrel cage. And maintenance. So maintenance is also very less in squirrel cage induction motor, and somewhat frequent maintenance is required for slip ring induction motors. Copper loss are low for spiral case. Copper loss are high for slip ring. Frequency efficiency is high, efficiency is low in case of slip ring. Power factor is high and power factor is low. Speed control, since there is no possibility of adding any extra resistance, so resistance control method is not possible and the speed control is also not possible. It runs somewhat less than the synchronous speed. Here, with the help of resistance control method, we can control the speed in spiral case induction motor. So speed control is possible here. Starting current is high, since we are using external resistance at the starting. We can limit the high starting current. So starting current is low in case of slip ring. Cost cheap and cost is expensive because of slip rings and brushes. Some extra parts we are using here in slip ring induction motor. Applications. Spiral case induction motors are used in lathe machines, fans, pumps, blowers, etc. In cranes and hoists, elevators, conveyors, and loads which require high starting torque, we use slip ring induction motor. So these are the construction and rotor types of AC machine, especially induction motor. So induction motor has main parts stator and rotor, and winding stator has winding, stator winding and rotor winding. It is singly fed machine. So three-phase AC supply is given to the stator winding, and it is asynchronous machine. So these are the induction motors are very widely used for industrial purposes, both three-phase and single-phase. Single-phase for domestic and three-phase for industrial purposes. It's mostly. So coming to the comparison, so these two in the view of prototypes construction. So brushes, losses, efficiency. These are it's all about AC machines, three-phase induction motors, AC construction, working principle. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.